Hey guys, I messed up my video on this one, so it's already written on. I'll just go back over what we were doing. So we're talking about the range, uh, which is a measure of variability. Okay, so if we go back to, let's change up the color since I'm doing it a different time. Let's do magenta. Okay, so these were the test scores we were just working on in the last video. The mean was 78, the median was 76.5. Okay, the same class takes another test, and here were their results on that one. And in this case, the median was 72.5, and I'm sorry, the median was 72.5, that's correct. The mean is 66.33. So it looks like the mean went down and the median went down. So it says, looking at these two sets of data, can I conclude that the students have the same performance on this test as the previous test? Well, even though the mean and the median both went down, you guys, look, a couple of students did, or at least one student is way higher. Okay, and we have in this case we have two students in the 90s. Okay, even though we have no students in the 80s. So can you really say that they did better on one test than the other? Okay, I don't know. You're going to have to analyze that and think about that. Like, would I be happy that some students did really well and other students did worse? Probably wouldn't call that a win, you know? If two data sets have the same or very close mean and median and possibly the same mode, does this mean that they generally contain the same data? And no, because, and this is where I did kind of this work right here. I'll do it again for you guys. Let's say we have two students take a test and the average of those two scores is 50. The mean is 50, right? So two students take a test. That means whatever they got, their scores added up together was 100. Well, there are many different ways that they could have added up to be 100. One student could have gotten 50 and the other student could have gotten 50 and the average would be 50, okay? One student could have gotten 90%. The other student could have gotten only 10%. Their average would still be 50. So just because you're getting the same number doesn't mean that you're really looking at the same data, okay? So down here, here's the important piece of what we're talking about here, the range, okay? The range is calculated by subtracting the smallest value from the largest value. So if we go back up, and I highlighted it in yellow up here, the smallest value in this first set is 69. The largest value is 91. When we subtract 69 from 91, we get 22. In the second set of data, so the range is 22 for that first set of data. In the second set of data, the highest value is 99. The lowest value is 57. When we subtracted 57 from 99, we got our range is 42. So our range is a lot larger in that second set of data. And that's because we had students that did a lot better and we also had students that did worse. Okay, so it made the range larger. All right, so what are we doing? We're trying to find the quartiles. So think about this word. We're going to talk to you again about it in a minute. Quartiles. Does that sound like another word? It kind of sounds like quarters. When we think of quarters, a quarter of something, we think of fourths, right? So it's really related to the median. That's what it's talking about. In this first set of data, I went ahead and circled the median. I counted them all up and then found that if I circled 77, I would have 6 numbers higher than 77 and 6 numbers lower than 77. So I know that was the median. Okay. this is something interesting. I have it circled in green. The median is also called the second quartile or quartile 2. And if you think about it, that makes a lot of sense. If we're talking about fourths and we're calling the median the second quartile, we're talking about 2 out of 4. 2 out of 4 is the same as 1/2. So when you take the median of something, you're cutting it in half, right? So it stands to reason that it is the second quartile. Now, to find the first quartile, you are basically finding the median of the first half of the data set. So what we're doing is we are just looking at these numbers and we're finding the median. And it did that right there, but at this time we called it quartile 1. The median of the first half is quartile 1. So that stands to reason that the median of the second half, or the median of the right-hand side, is quartile 3. So in this case, they took the top half of the data to find quartile 3, right? And of course, when we have an even number of numbers, to find, when you are finding the median, you have to find the average of those two numbers. So here we took 60 plus 65 divided by 2. You got the quartile 1 is 62.5. And below, we had to do 90 plus 91 divided by 2. So in that case, the median was 90.5. Those, you could have also just said, okay, what's the number exactly in the middle of 1665, and what's the number exactly in the middle of 9091? And of course, it's the same number. Okay. All right, so have you guessed why we call them quartiles? Well, I kind of spoiled that for you before. It's because you're putting them into fourths. What I looked at here is that we're talking about fourths, but really you're just using these 3 values, right? Quartile 1, quartile 2, which is the median, and quartile 3. Well, that's because the fourth quartile, the fourth, right, is the whole. That's all of the numbers. And down here, the 0 fourth is none of the numbers. So even though we only have that quartile 1, quartile 2, quartile 3, you can see all of the pieces there. Okay. Last but not least, we're talking about the interquartile range. Also important, will be on the test. The interquartile range, you take the third quartile, in this case 90.5, minus the first quartile, in this case 62.5, and we get our interquartile range is 28. I went ahead and also put here our range, which was the highest value, 120, minus the lowest value, in this case 0. So our range was 120, and our interquartile range was 28. And this was a short video. Let me know if you have any questions.